Hello guys, here we are again with a brand new design pattern for you. This one is gonna be nice and simple and I hope short because it's a very easy design pattern. It's a prototype design pattern. So without further ado, let's go and look at the definition, the scope for the prototype design pattern. As you see here in my project, I've made just a directory, and inside here just two images that I want to show you to start the discussion. So as you see, the prototype design pattern used to specify the kinds of objects to create using a prototypical instance and create new objects by copying this prototype. Well, as usual, a little bit too abstract, but basically what this is saying is that here we are still concerned about creating new objects, and to create this object we actually don't want to start from scratch, but we base ourselves on one object that already exists, has already been configured, and we create the new instances in some way by copying the prototypical instance, by copying the object that already exists. And here you can see the UML diagram of this pattern. As you see, it's pretty simple. Actually, it can be even simpler than this because actually here the inheritance is not really needed. The fact that these prototypes are members of a family doesn't really matter. I think it was done this way just because if you don't do even one inheritance hierarchy in a pattern, it looks too simple. But basically what's going on here is that some clients wants to create an object, and to create this object it copies an existing prototype, copies an existing object that's already configured. And yes, you could actually have a family of objects, but that's absolutely not required and often doesn't happen in the real world. And what actually happens is that sometimes the superclass helps you by defining the method that you can call to copy the object. And you probably have seen this method already if you programmed a little in Java or C#, because these languages actually offer natively some support for the prototype pattern by defining a method that allows you to copy an object immediately with the call to this method. But I wouldn't say that this is a fundamental part of the pattern. And also here, what is not shown is that usually the client won't actually talk directly to the prototype to clone it and to get the other instances that he needs, but he will probably interact with some kind of repository or directory of objects to ask for the clones for the object that he needs to copy. We could say that the prototype pattern is the opposite of the builder pattern, because we use the builder pattern when we want to give the client the possibility to create objects by customizing them in a very deep way. We want to give him the possibility of creating objects in very different states, and we usually give him a fluent API, an easy API to do this, to configure the objects in detail. But with the prototype design pattern, we actually are interested in the opposite situation, when basically most of the objects that the clients desire will be in the same state, and maybe the client will configure them further a little bit, but mostly the client is interested in getting objects that have a standard configuration, one configuration that's typically too expensive to achieve with a simple call to the constructor. And to make this discussion more concrete, let's go and write some code to give an implementation of this pattern. So let's get rid of the UML diagram, and here we will start with the creation of a new class. I guess we can call this class soldier. You will see why. And let's say that the creation of this soldier is actually something quite involved. So we want to have lots of parameters here, double delta, double, I don't know, variance. Let's choose something that make this look complicated. Okay. So we won't do anything with these parameters. They're just here to remind us that if we want to use the prototype pattern is probably because the creation of the object, of the original object, is quite expensive. And then let's say that we also have some method like test, which also is quite complicated, and So double N, double M, and string source, I don't know, and another method which is called, let's say, train, double tolerance, and double X, Y, and Z. There we go. And let's say that these methods are actually void. So, also for a reason that will be clear in a little bit later, let's say that also a soldier has a relation to another object, like for example, I don't know, a gun. So let's go here and create another class, and we call it gun. And the gun actually has only one property, which could be, I guess, the power. So let's say prop. Let's see if this works. Great. Let's say that this is the power, and the kind of this will be, I guess, int is good enough. And let's say that also the constructor can be used to initialize it in power, and so power equals power, I guess. So we have a gun. That wasn't too hard. And so let's give the soldier a gun. So gun, and I guess we can call it gun because I'm so imaginative. Okay, so now we have a soldier with this beautiful gun, and the problem is that actually creating this soldier is quite complicated because we have to know what are the right value of the parameters that we have to pass to instantiate the soldier, and then we probably have to train and then test the soldier. So the whole process of creating the soldier and getting it ready to action is not easy. So what we will do is that to facilitate the operation of creating new soldier is offer a method that can be used to clone an existing soldier. And to do this in .NET, the procedure is this one. We want to implement the interface iClonable, and then we go and implement the interface. And as you see, the method that we want to implement is this method clone. And luckily, we don't have to do everything by ourselves because, as I told you before, a lot of languages offer already support for copying objects, and so does C#. So actually, what we can do is just use an arrow function and just reuse the member-wise clone method that .NET so kindly already offers us. So now our solder implementation is complete for now. We want to implement also some kind of reader repository so that the client can contact the repository to get new clones. And since we're talking about clones, I think the best repository to create will be called Empire Base. I know I'm a nerd, I'm not even trying to hide it. So now we have the Empire Base, and the Empire Base actually will have one soldier that will be the prototype of all of its army of clones. So we can say private soldier, and I guess we can initialize it. We can initialize it inside the constructor of the Empire Base, and here we will instantiate our soldier using our old best friend, the constructor. And here we say that for some reason we have to use these values. Don't ask me why. Let's say perfect soldier just need to start this way. And another one, why not 1000? Such a beautiful number. But we are not done yet because we also need to train our soldier. So let's go on and train it. Let's say we need 0.001 of tolerance, and then the coordinates. There we go. Pi, of course, and 6 and 9. Why not? And then we also want to test our soldier. Maybe I should have made this method return a boolean, but it really doesn't matter. Test, and these two doubles and a string. So let's say 1.9, 2.5, and A, B, C. Why not? Okay, so when we start with an Empire Base, we build our prototype. We are saying that that the building of the soldier is actually something that's quite involved, and now we want to offer the possibility of cloning and building our big army of clones to our client. So what we want to do, of course, is to create a method that we call that will return a soldier, of course, and I guess we can call it new clone. And what will this do? Well, they will just say, we can actually, I think, just make it a bit shorter and say that new clone will just say, all right, let's give me a new clone of the base soldier. So let's do like soldier dot clone. And of course, we have to do a cast to the type that we want to return, and I could do a cast, or maybe I could just do an as operator, which in this way I like it a little bit best. So the new clone method will just call the clone method on soldier and then return the freshly instantiated clone to our client. All right, so initially our client is extremely happy about this arrangement. He's paid us dearly. So just to do a little bit of review. Here a soldier, it's an clonable, so when we call it clone, it will just use the native method member-wise clone to get a clone to get a copy of himself. He has a gun, is is initialized in a very complex way, is being tested, is being trained, so I guess we are ready to go. It's our Empire base, and to test if this is gonna work, I guess we want to do, as usual, a little bit of unit testing. So let's go here in our project, in our XUnit project, and I guess we want to create a new folder just to keep things a little bit organized. So let's create a new folder for the prototype, and then let's add a new class here. And I guess we can, since as usual I have so much fantasy and imagination, I guess we'll call it prototype test. So we want to use XUnit, so let's get this out of the way. And here, I guess we can get rid of this. So let's create a new method now. So let's go and put the fact attribute, and we can say public void new clone. And here, as you see, are already done the using of the design pattern creational prototype namespace where I defined all my classes. Here we want to create an Empire base, and I always make the mistake of calling it base, but base of course is a reserved word. I don't want to use the @ symbol, so let's call it Empire base and equals new Empire base. And this will take care of instantiating the very complex initial prototype. So now we want to construct a few soldier, a few clones, and get started with our armies. So let's say soldier S1 equals Empire base, new clone. Here we are with the first one, and then soldier S2 equals Empire base dot new clone, and we got two brand new clones. And just to make sure that we are not doing anything terribly stupid, let's say that we want to assert that these are not the same objects because we want to have different clones. So let's assert that S1 and S2 are not the same object. And let's just start with this test and see if at least this checks out nice. So let's rebuild and let's go to our unit tests. And let's see what's inside here. Here a new one. Let's run the test and hopefully this should check out fine. And in fact it did work. But now let's go back to our soldier class for 1 second, and let's think a little bit about the gun, because gun is important for a soldier, and actually we wanna think about what happens when an object has a relationship with another object. For example, here with our gun. Well, first of all, the soldier is not initializing the gun, so let's do it here. So let's say gun equals new gun, And let's say that we start with 100 units of power. So now I think we can extend a little bit our test by saying that, for example, we want to assert are equal, and then we want to see that, for example, the two guns have the same power. So, for example, we could say we want to assert that the two guns have the power that I expect. So let's say assert S1 gun power is equal to 100, and of course I have to the first position is for expected and the second for the actual. So this is the right order. And then again assert equal, and here 100 again, S1, S2, sorry, dot gun dot power. So let's check if both the guns have the power that I expect, that is the same power that the initial prototype had. Let's go to our unit test, let's go again with this one, and it checks out fine again. Good news. So, this is all nice and dandy, but here comes the bad news, because let's say we want to customize, for example, S1, and say that his gun should have the power of 200. We want to double it. So what happens? Well, what we expect here is that, of course, this is going to be 200 and this is going to be 100, right? Because S1 was constructed from the clone, and so it should have the same power, and S1 has been constructed from the clone, has been modified, right? So that was actually what we might naively expect, and of course you know that you already know that something is not gonna work here. Let's see. Boom! We got some problem here. And you see, the problem is that we expected 100, but we got 200. That sucks. Now the assert is actually this one. So the problem here is that it looks like when we change the power of the S1 soldier, we have changed also to the same extent the power of the S2 soldier, and you probably already have an idea why this is happening. The thing is that if you go back to our soldier, when we clone it, we use member-wise clone, and what do you think this method is doing? It's just making, as the name says, a copy of every member of the original class. But what it's making is a shallow copy. It's just copying the memories, duplicating the memory. So what happens is that this soldier has a reference to an object of type gun, but when a soldier gets cloned by member-wise clone, what happens is that you create another soldier which is totally identical to the first one, and so it has the same reference, to the gun, but the gun doesn't get copied, just the reference of the gun which is in the soldier class. So now the problem is that when we create and clone 1,000 soldier, 10,000 soldier, they only have one gun. They all share the same gun, and that's probably not what our client desires, an army with just one gun. So we actually have to rush and immediately correct this little problem. So what we want to do here is that we want to do what is called a deep copy. Deep copy means copying not just the original object, but the whole tree of dependency that this object might have. In this case, it's a very simple dependency tree because it's just one object, a gun. But you can imagine that sometimes the situation can be much more complicated because, for example, the gun might have a reference to the projectiles, and the projectiles might have a reference to something else, and then the soldier might have references to other objects, like, for example, a direct superior. So actually sometimes when you want to clone in a deep way an object, the situation is quite complicated and it's very hard to do it by hand. Here we could do it by hand quite simply, but just creating a new gun and assigning it to the new soldier when we clone it. But so the problem is it's easily solved. But I want to talk to you about the general situation when the situation is not so simple. So when the situation is not so simple, what we want to do is we can actually exploit something that already exists, like we do every time we want to be lazy, and this kind of laziness is actually a very good virtue for a programmer. So what we want to do is we need to create a new method, which is going to be a method that yes, returns a soldier as well, and we'll call it deep copy. And this method is going to be in charge of making, like it says, a deep copy of this object. And again, if you wanted to do it by yourself, it will be quite difficult if you want to be general enough that this method works in every situation. So what we are going to do here is exploit one mechanism that already exists, and it's the serialization mechanism. Because if we think about it, when we serialize an object, then we serialize also all of its dependencies. All this difficult recursive job of navigating a dependency is already being done in the serialization mechanism. So I think we can exploit this, and basically to make a deep copy, we can serialize a soldier and all of its dependencies, and then deserialize it immediately after, and there we go. We have created a deep copy of the original object. So what we are going to do is exactly this, and we are going to say, for example, using, and here we are going to use a memory stream. We're going to use a memory stream because we don't usually, when you serialize something, you probably are going to write on a file system, but here, of course, we don't want to take the performance hit of going and interact with the file system. It's totally useless. We just want a stream where we can write and read, like what we do when we use a file. And a memory stream is exactly what we need for this. So let's use system.io, and then here we are going to use a binary formatter. That's the class that will help us to serialize our object. So formatter, I guess it's a good name, is new binary format. No, not binary reader, new binary formatter. Okay, I don't have the namespace. New binary formatter, and of course we're going to have to use the namespace. And as you see, while I'm doing this, I'm just basically using system.io and system runtime serialization formatter binary. And then what we're gonna do is, like I said, just go on and serialize our object. Our object, which one is our object? It's this, right? We want to serialize ourselves on this memory stream. Why? Because now we reset the memory stream by saying that the position is 0, because we want to go and read on this memory stream from the beginning, and then we're gonna read exactly what we just wrote, and in this way we will get our deep copy. So I can say soldier other equals, and then there we go, formatter, deserialize from the memory stream. And of course, even here, I have to make a cast to its right type, which is soldier. And then when we have done that, I guess we can just return the other soldier. I could do it in just one instruction, but it doesn't really matter. Return other. Well, this looks great. Let's see if it actually works. So let's rebuild our project. Oh, actually, we have to do another change, which is right now the clone method is just using member-wise clone, and of course we don't want to do this. We want to make it so, and I won't change it. I just comment it because so you can see the two approach at the same time. And actually, this time we want to do something different. We don't want to use member-wise clone. We want to use deep copy. There we go. So now our soldier is probably much better off because every soldier should have his own gun, which is probably what our client desires. So let's go back to our prototype test, and this time I expect that the soldier will have guns with different power and with the power that I expect. So let's see if this is the case. Drum rolls. And no, what did I messed up here? Okay, probably some of you already caught this and were just evilly waiting for me to crash. But it's okay that we discovered it this way, because this way is also easier to explain and to remember. As you saw, the problem was that the runtime is complaining the serialization exception, and the problem is that our soldier is not marked as serializable. This doesn't have anything to do with the prototype pattern. It's just about the fact that when we want to serialize a class, we have to declare that this class is actually serializable, that it makes sense to serialize this class. So all we have to do is to use an attribute and go on our soldier and say that our soldier is actually a serializable object. And all we have to do is this. And we have to remind ourselves also that the soldier has a gun. So of course also the gun must be serializable, because that's also part of the dependency tree that's going to be serialized. So the guns too must be serializable. And this time we should be good to go. Let's see, because we never know. And there we go. Our test works, and it proves that this time every soldier has its own gun. So we are working with a deep copy. We actually get in different objects, and each clone has its own gun. So I guess we are ready to conquer the galaxy. And this is pretty much all I wanted to tell you about the prototype pattern. I hope I'll see you on the next pattern.